All right, let's check out time. Time. When we talk about time, there's two ways we generally talk about it. One is, what time is it? You can see here on my clock, it's actually 10, 12, and 52 seconds. Okay. This says it's 12:47 and 36 seconds. Okay. Um, or you can measure how much time. So this is like a stopwatch. You start it at zero and it works its way up. And so this is going really, really fast. And then every time you accumulate um, a full minute, it goes and adds one here. Okay, so this would be hours, minutes, and seconds. You can see here it's hours, minutes, and seconds, and it even takes it into hundredths of a second. Okay, when we are working with time in our class and in physics, we will always be using it just in seconds. And so what you need to do to convert is you take the hours and you multiply by 60, and that gets you 60 minutes. So 1 times 60 is 60 minutes. But we also have this 26, so we have to do plus 26, and now we have 86 minutes total. Notice I haven't touched this 31.25 because I don't want to multiply that by anything. I want to just add that onto my seconds at the end. So I have 86 minutes. If I multiply that times 60, oh man, that's tough. I might have to get a calculator or do some long multiplication. The zero is easy, but 6 times 6 is 36. I carry a 3. 48 plus 3 is 51. So this is 5,160 seconds. Okay, so this is the number of minutes, and we're multiplying times the number of seconds per minute. And you can see here the minutes cancel, and we get this many seconds. But don't forget, we also have 31.25 other seconds that we started with. And so this is a total of 5,191.25 seconds. Okay. And so this is what we would have to use. We don't want to use this like weird mixed number of fractions and stuff. Okay. So when we use a stopwatch, you just pick your starting time. Okay. So that's like your initial time is typically 0. And then you click to end your stopwatch and it tells you how many seconds have elapsed. Okay. But it's delta t. This delta is not the delta variant. This is the change in time. How much time has elapsed in some interval? Okay, so and then we'll always want to convert it into seconds if it's not given that way. Okay, now we will frequently be taking measurements to measure changes in height or change in distance or change in velocity or change in something over time. So time will be our x-axis, and typically we'll start at 0 seconds and we'll just keep measuring for some amount of seconds, and you'd set up your scale here. And then maybe we're measuring the height of an object that's flying through the air, or the distance that something has traveled. If we have like some race car or something, some wind-up car, or the speed of something that we measure. Okay, so time will almost always be our x-axis, that as time passes, we're trying to measure how things change. Okay, and we'll look for patterns in these to see if we can start learning stuff about how stuff changes over time. Okay, and then when we talk about measuring things, okay, there are two ideas that work side by side each other: accuracy and precision. Okay, so notice here, this guy is really, really good at hitting the target. That is both accurate and precise. Okay, notice you can be accurate but imprecise. So he's accurate, he's hitting it around the center, but not very close to the center. Okay, this guy keeps hitting the same spot over and over and over again, but he's missing the mark. So like if you're not using your ruler properly, or it's just a bad ruler that you can't read the numbers or something, okay, the precision is based on the limits of your measuring device. Okay, some things have lots and lots of little dashes that let you be more and more precise. Some of them have big spaces between their dashes on a ruler or something like that, or a stopwatch might go to the hundredths place or the thousandths place. So the limit of your measuring device determines how precise it is. Okay, the accuracy is the quality of the device and really the quality of the user. Okay, when you have low accuracy and low precision, you're missing the mark. You don't even know what direction you're missing. You have no idea. And so our aim is high accuracy. So that's a good measuring device, and to be precise with our measures, okay? And we get as precise as our measuring device allows. All right, so we're going to do some practice with converting some numbers, and you can then do a mastery check. We'll see you soon.